we talked about how citations are distributed. Here we can see the distribution of references in article. This is a number of, it's from different journals from the PLOS group. It's an article by Vincent Larivière. And most of the the references, like when you're in the paper, you have references, are in the introduction or in the discussion. But in the methods and results are very minimal. So again, it shows again that citations are used to relate to concepts and theories. Their reference is absolutely necessary in order to understand the content of the citing document. And you mentioned being agree or disagreed. You have I put in the wrap-up documents. There's a very nice study on it's good. Do you want to be cited if it's to be criticized negatively? You know, there's been articles specifically on that, if it's positive citations or negative citations. But the big thing is in scientific platforms and imaging facilities, you know, most of the impact usually is, or most of the activities are related to methods and results. And there's rarely people cite or reference anything there. So that could be one of the reasons, of the many reasons why most of us are still invisible in the field of publications. So, and as discussed also, the citations, the mean number of citations are so different by discipline or specialty. So there's a real need for standardization. The number of citations varies over time. Some discipline, you have the citation very quickly, like within 2 to 3 years, others comes much later. You have some late bloomers articles as well. And as you said earlier, you know, after 10 years in certain fields, I mean, everything over 10 years is just not considered, which is a shame. It's always a non-parametric distribution, meaning 80% of articles are published by 20% of authors. It's like a Pareto distribution. So there's some highly cited articles and many, many, many poorly cited articles. It's really not a fair distribution of the citations. If we were to look at citation as an impact measurements for normalization, on the left hand of the graph, you can see by different fields the mean number of citations. So, for example, biomedical research, you have a mean number of 45 citations per paper. It's usually like you can see for the first 2 years in the light blue, and the third year is a dark blue. In psychology, Earth and space, there's a lot. If you go to humanities or arts, nothing, just because they just don't publish much articles. Engineering and technology, not much either. Social science, the mean number of citations is pretty low. And one thing to consider, if you were to plot the raw number of citations versus a normalized citation, so you normalize by field to be able to compare the different fields together, like if you want to compare biomedical research impact versus mathematics, you need to normalize by field. There's really no correlation between the two, showing that if you do not normalize and use raw citations, you have a huge bias in giving high impact to number of citations that do not relate to the field. So it's very, very important to normalize. There's different ways to do that. I didn't go into that today, but I'll try to put a couple of references for a normalization approach. So what we did with Claire and other colleagues back in 2019-20, we got funding from NSERC in Canada to study the impact of scientific platform on research success. So this is a report. So it's not officially published in a journal because we ran out of funds before the end, and it's still a work in progress for my thesis and other work I have to continue that work. But we have a report that has been highly downloaded and distributed. And one of the key findings, it's not the only one in there, is that, so this is a case study. So we took a university and all the platforms in one of the faculty. And we did a comparison between, so it's about 12 platforms, 13 platforms. So there was only on the PI names, 86 that were users of scientific platform and 26 that were non-users. And we use that to compare in blue, the one that were using the platform, and in red, in green, the one that were not using them, and showing that for the mean relative citation index per researcher was much higher and statistically significant some years between the user group and the non-user group. And the same was demonstrated with grants. So the mean of total funding for researchers with a TREE Council, which is funding bodies in Canada, had a much higher amount of money than the one that were not users of platforms. So it's preliminary information. We need to dig more into that, but just that is pretty striking, I think. So
there's a couple of questions, Laurence.
Yeah. Okay.
Could it be that if you have more funding, you can afford to use the facility?
That's part of the things we need to dig into. That's one. And also there's certain fields of research I don't necessarily need to use a platform. So that's those kind of things that we need to elucidate more. You're right. More funding. It's like a virtuous cycle, right? More funding gets more people to work, so you get more people, then you get more funding. Blah blah blah. Britta.
And these different users also were doing the same type of research.
Yeah, that's another
also
thing.
Be biased by they just do different type of research.
What we did is it's normalized citation, so that we minimized the effect of being in different fields. And of course, it's a whole faculty. So it's a very different types of research done there. So we didn't go, the granularity on that paper, right, doesn't go into more buckets of division. But that's the next steps. If we manage to get even more data, then we can potentially be able to really isolate, more specific fields and see the kind of curve it gives rise to.
I just wanted to add that they were all at the same institution, so that should normalize a little bit the research environment and so on.
Yeah.
Except that they would be at different career stages, but.
Mm-hmm. Thank you, Claire. So I have to. So if you see someone else talking, please let me know, because raising the hand, because I don't see people's face to be able to see my screen properly. So now I'm going to talk about two big impact factors that are still in use today. So the first one is a journal impact factor. So the journal impact factor concept origins in 1927, when Gross and Gross, they were brothers, but chemistry professors in a college in the US. So they ask themselves this question: what files, scientific periodicals, are needed in a college library to successfully prepare the student for advanced work, taking into consideration all those materials necessary for the stimulation and intellectual development of the faculty, right? So basically, what do you need to get to make sure you have the right document for your students? And then it gave rise to the question of what do the librarians need in university to purchase so that they provide the most impactful journal to the researchers. So it was further developed by Garfield in the 60s, also one of the Science Citation Index funders. The first step in obtaining a more meaningful measure, if important, is to divide the number of times a journal is cited by the number of articles a journal has published. So I'll explain in the next slide why it's important. But the first need was to understand, do this journal is needed by the community? So is it cited a lot? This is what they looked at first. And then they realized that some journals had a lot of articles in them and some had much less articles. So normalizing by the number of articles in the journal seemed a good idea to kind of really compare apples with apples. And what about the impact factor, the journal impact factor is measured over the last 2 years. So you measure the citation of the year of interest divided by the number of publication of 2 years before and the number of publication 1 year before. So if you want to measure the nature impact factor, had, for example, 40,000 and so citation in 2017. So you take all the citation in 2017 and look at the number of publication for the year 2015 and 2016, which gives an impact factor of 41. But it's analyzed only for 2 years, and we mentioned that you know, citations, large span can be a lot more than 2 years, and sometimes the peak is not after 2 years, it's 3, 4, 5 years after sometimes. It doesn't presume anything on individual articles. The fate of your article can be completely different than what is predicted through the impact factor. So if you look at here, if we take Nature, the impact factor, it's, I guess, a different year, is 38.1. But if you look at individual articles in Nature, you have a few that are very highly cited papers, but the big majority have lower citation than the impact factor. With +1, its distribution is even more in the low end, but it is closer to what is really with the citations. But a few very highly cited paper can really skew the impact factor. It doesn't mean anything about your own paper. So this that to keep in mind, but it's still very prestigious. Maybe because I have a rejection rate of 80 or maybe 90, 95% now. Another one is a H index. So the H index can show in many, I showed it earlier with my own data, was created in 2005, so it's not that long ago. I mean, it's 17 years, but it seems like yesterday to me. And it's the number of paper that has more than H citation, H being your H index. So it wants to combine production and impact. It is completely dependent of scholars' age and the number of publication. And it can never be more than the total number of articles that you have, independently of the number of publications, citations, sorry. And if you look at here, it says, I like that case study because it really gives you an idea of how absurd this one is. So you can take, for example, Martin and Martin. Martin, published regularly, has 10 citations per article, which is great. So it has this person has an H index of 10. And with a total of citation of 100, which is citation per article of 10. So it's okay if you have a very regular distribution of citations, but we've seen that within your own career and in the general scientist publications, it's not a normal distribution of citation at all. In my case, I participated in one article that had over 600 publications, and then the next one is 50. So 600 citation and next one is 50. So it's very not evenly distributed. So the Martin case is closer to what really happening. So this person had one relatively high cited article. I mean, the first 4 ones are pretty good. And then it goes down to some of them that have 0, but she still has an H index of 5 because she only has 5 articles of over 10 in the number of citations. If she wanted to have 6 as an H index, she would have needed 6 here. So if you have 6 as an H index, you need to have at least 6 articles over 6 citations, and then it's 5. So poof, it moves to H index of 5. It's all round number. But in fact, if you look at citations per article, it's more than twice than is her colleague Martin. So it really doesn't reflect the impact of the articles or the person, sorry. And just to show that it's still not, the mentalities are still not changing, and there's a huge science groups that are working on bibliometrics that are really condemning for a very long time now, more than 15 years, this kind of approach. And thanks to Claire, she showed me this article published in University Affairs, and the link is below if you want to read everything. It's, do you know how to measure your research impact? The H-index and journal impact factors are two well-known methods to determine how well your research is being received. And she's going on in the article explaining that this is great to use that. And it's for graduate students. So it's so dependent of how long you've been in the business that I don't expect them to have very high H-index.
I thought this was really interesting because it just came out last week, and
yeah, it's like
a Canadian university magazine that's pretty widely distributed across the country. So yeah,
impressive. So next, I really want to thank Vincent Larivière. We've been collaborating with him for the study we did, and I'm still closely working with him and studying with him. So most of, not all, I did some of the work, but a lot of what you've seen here is coming from his articles and some of his slide decks. So I don't know if we'll get a citation out of that, but it will help us today with his work. And I really invite you to go into what his group published. There's a lot of very, very interesting insights on how experimental research, as we know, our biomedical research is working. And it's really, and the articles are usually very, very relatively easy to read. He has a way to write that is really accessible. So to finish this session, so I don't know if we want to go in breakout rooms or not, but I'd like you to reflect on how all what we discussed today in this first part, and see what you think. Did you learn something new, for example, or did it make you think differently about publications or journals or citations and so on?